So it's very easy to make liquid nitrogen boil. The inside, you can see the frost accumulating on the outside of this container, and even if I just blow on it, it boils. The liquid on the surface will boil. Now the other kind of neat thing about liquid nitrogen is that when it boils, it expands 700 times its volume. So if I take about 1.5 milliliters of liquid nitrogen, once it's boiled and reached room temperature, it'll be about a liter of gas. Now I'm going to see if I can demonstrate that by taking a little bit and pouring it into this glove, and then sealing it up. And that's going to go, oh, okay, well that was more of a fizzle than a pop, but you get the idea. It will expand pretty dramatically. It also makes things brittle. Dump them in there. So that flour now is very brittle. I can take it and it shatters just like glass. Maybe.
All right, so what do you guys know about chocolate?
It's good.
It's good. What else do you know about it? Anything? This is cocoa butter. Okay, take a whiff. Okay, so that's cocoa. That's cocoa butter. So that's one of the two key ingredients you get in from the cocoa beans. And then you're all familiar with cocoa powder. All right, like if you make milk chocolate or whatever, chocolate milk, right? You're going to use cocoa powder. So cocoa powder and cocoa butter are two of the key ingredients in making milk chocolate, because that's the proper term. All right? So then, with conching and refining, what happens is that you mix all of those ingredients that we have, okay? But notice how this is basically liquid, but the cocoa butter is solid, right? So this is warm. If you were to put your hand on this, you'd see that it's about 60 degrees C, so it's pretty warm. All right? So that, my friends, is the science of chocolate. And now we have a sample for you guys. All right, so now the chocolate.
So first of all, this is explaining just the same principle as why ball floats on water.
Yeah.
This is buoyancy, right? Everybody likes it. And you know water moves, right? So if I
probably 15 stories on a rope and a harness. Now his tail tucks in a little bit, but we get over that. So does mine. So, but he's able to do that. Confined space rescue. And one of the problems that we had in structural collapse is the building may have been down for a few hours, but it may take us a day or 2 or 3 to get into the victims, because that building has to be secure for us to work our way through as rescuers. The dog, however, he works completely off lead. He can search his way through, and the problem we were having is finding out, 1, the location of the people, and 2, was how to mark the people when we found them and then get them something. So that's where Professor Fairborn came in with his ideas, and we've solved some problems together.
Sometimes the handler can hear him. So when the handler hears him, the handler can actually press the button and release the bag. Normally, the dog is so close, we've never been more than 1.5 feet away from the target. So they can reach out and grab the bag. Inside, you can have a water bottle, you can have a first aid kit, anything you can fit inside that bag, or a radio. It's often helpful to talk to the victim, ask them what's going on, because they actually know.